Cool. Okay. Thanks everyone for coming. We're recording now, so if you don't want to be recorded, just be aware of that. Have a tutorial today excited about. It's about social media preprocessing, how to deal with text from social media like Twitter and Facebook. And we have Steve Wilson, who is a professor at Oakland University. Yeah, we'll get started. So in case you don't know, I'm Ian. I'm one of the co-organizers, and I am currently a postdoc at University of Michigan. And I'll let Katie introduce herself. She's another co-host.
Yeah, just briefly. Hi, I'm Katie Keith. I'm the other co-host along with Ian. I'm a postdoc at AI2, do NLP and computational social science. And Steve, go ahead and take it away.
All right, thanks. So I'm Steve Wilson, as Ian mentioned. I'm in the computer science department at Oakland University, which is actually in Michigan, contrary to the being in the less popular Oakland in the US, I think. We're going to talk about social media preprocessing today, and it's going to take place all inside of this collab notebook here. So if you want to follow along, you can access the notebook at this link here, and I think Ian might post that in the chat as well. And then this GitHub repository just has the notebook itself plus the data that we're using here, but that will all be taken care of and loaded as we get started. So if you want to be able to change and mess around, run any of the code and do things as we go along, you can just go to File. I already am open in Playground mode, but if you're not, you should see in here open in Playground mode. Then you'll get this bar at the top. Then you can change anything and it won't affect what we're doing. So if you want to follow along, feel free to do that. And then you can modify, run anything as we go. So the first thing we need to do is just some setup. All you have to do is click run. That's going to load a bunch of libraries, data, some functions that we'll use later. So if you want, get that started, and while we talk about a little bit of background, and then it should be ready to go when it's time for us to run some code later on. So I want to start with a little bit of background on social media data and what makes it different and why preprocessing is important. And I want to argue that it is important. So a lot of traditional text preprocessing pipelines include steps that remove things that we don't want for our final output, right? So sometimes this is considered noise or extra information or something maybe we just don't know how to deal with properly. So it can either be normalized in some way or just totally removed from the text itself. And when we think in terms of different features that might appear on social media, some features that are removed by, again, I'm saying traditional pipelines, maybe the ones that aren't considering social media data, include things like special characters. So just by that, I mean all kinds of non-alphanumeric characters that oftentimes are stripped away and removed, since maybe they're not considered content that we care about. Out of vocabulary words, so maybe things we don't have an existing representation for because we haven't seen that particular token before, might be removed. Things like emoji might be removed. URLs might be removed based on checking some patterns and getting rid of those. Some known social media features might be removed. So maybe you know you have social media data, but you're using a pipeline that is kind of expecting more standard text. And you know there are going to be things like @mentions, retweets, markers, hashtags. So you'd get rid of those to get to more what you might consider normal text. Or even non-standard casing. You might lowercase everything. That's a really common preprocessing step, is to lowercase everything. And so you might take text that looks like these examples here and convert it all to lowercase versions. So other than just removing, you might also just replace some of these with some standardized tokens. That's another kind of step further you can do rather than remove. So instead of removing URLs, maybe you just put a token that says URL. So now you know, at least there was a URL, but we don't know what it was. And that can be good as well. It can be useful to do that. I don't want to say that that's the wrong approach to take. if your goal is only to consider what might be more standard language features in your analysis or your modeling, that might be totally fine to do. But I want today to think a little bit about what kinds of information actually are encoded by these features that we might be removing. So by normalizing them or taking them away, what information might we be losing that we can't use in our analysis and models anymore? Okay, so today I want to think about what you might be missing if you take that approach of just removing that kind of thing. We're going to talk about some alternative approaches you can take to handling these features. And I want to also think about when you might want to do that, because I think it's important to kind of tailor it to your specific application. So looking at these examples here, does anything jump out to anyone in the audience in terms of what useful information might be lost, or a certain task that you think you might want to actually keep some of this information and figure out how to have properly handle it? If anyone wants to share, you don't need to, or if you want to share ideas in the chat of things you're thinking about. For me, some common ones that come to mind, sentiment analysis is a very popular task for NLP. Certain emojis, like in this example, in this row, we have this emoji with the hearts around it, might indicate positive sentiment. We might get different sentiment even based on the capitalization. There's a link at the end here of a paper talking about how casing is related to sentiment as well. Those kind of features might be important. Giving more context to the messages, who is the message directed at, might even change the meaning of our messages. And certain special characters like the # hashtag symbol actually indicates something very specific on a lot of platforms. So just removing that might remove some useful information. And we could go on and on with a lot of other examples. But just as we're going through this, try to be thinking about different use cases and applications and the kinds of information that you might be able to get from these features. So I want to give a little bit of a preview of where we're going with this, looking at 3 specific cases. One is emoji. So I want to think about what if, rather than removing emoji, we could use them in our analysis in some interesting ways. So did you know that actually emoji are compositional? Many of them, not all of them, are, and we can extract the individual elements of an emoji. So in this example, there's this particular emoji, which is actually composed of these other 3 emojis, which is a person plus medium skin tone plus microscope. And the actual under the hood representation of this first emoji is actually nothing more really than these other 3 emojis smushed together. So we can actually dig into these compositional emoji and see what are the different elements and use that in our analysis. And we'll talk about how to do that. For one example we'll show later is how we can take these Twitter accounts. These are all coming from popular celebrity type accounts with many, many followers. So we're not trying to show any information that people wouldn't expect to be kind of public in this tutorial. But for example, we can break apart all of the emoji used by these different accounts and look at which skin tone modifiers were used most often by each of these users and how often they use that particular skin tone modifier across all of the emoji that they used. And we'll show how we can get to this point later on. We'll also show how you can convert emojis to plain text descriptions of those emojis. And there's some work that suggests this can actually improve classification performance if you include these plain text descriptions in addition to just the emoji themselves. Looking at hashtags, what if instead of just removing the hashtag or the entire token, we were able to consider the individual words that make up a hashtag? So we can actually use some classic NLP algorithms, the Viterbi algorithm, to find which combination of words is most likely given a sequence and use that to split hashtags apart. So we could go from this kind of hashtag what a day to the individual words what a day. And maybe our downstream applications are a little bit better at handling these kind of split apart hashtags rather than the entire thing. For URLs, I want to think about what if instead of removing them, we tried to extract some useful information from them. So we can actually parse the URLs and get some important pieces from them, or even try to go to the URL and get the data from the web page itself and even use that in our analysis as well. So we'll talk about how to extract domains. So given a longer link, looking at the domain itself might be useful, or given a longer link, getting all of the text that's at that web page. And then we can use that as part of our, in our NLP pipeline as well. Okay, so those are some things we'll show how to do very soon. Today, the main kind of takeaways I want to have are being able to think about which features in your social media data sets might pose challenges for traditional pre-processing pipelines. We'll talk about some approaches you can use to handle some of these things we just talked about, and some Python code you can use and examples to show how to actually do that. And you can practice along the way. Again, you can access this notebook, open it in playground mode, and try anything, change anything you want. Okay. We'll talk about a bunch of different tools and libraries. We'll go into more detail, but if you just want kind of a summary of some of the resources, or if you want to learn more about the basics of text pre-processing later on, you can go back and check these resources. So as we talk about this, I want to just have these two guiding principles. One, pre-processing does matter. I want you to think about how it could matter and not treat it as something we just need to get out of the way so we can start our analysis, but really think about the fact that the pre-processing can directly affect your analysis and your ability to do your analysis. The second thing is the right pre-processing steps can only be decided in the context of your application. So I don't want to say that there's one correct way to pre-process all social media data. That's really not true. It really depends on what you're trying to do with it. So we need to think about these kinds of questions. These are 3 questions I might ask yourself if you are working on a social media data set. So think about what you're trying to model or measure. And then in the context of pre-processing, does the pre-processing actually give you the information you need to model or measure that? What methods will you be using? And does the pre-processing give you the output in the right format that those methods expect as input? And finally, what are the unique features of your data set? Think about what makes your data set distinct and whether the pre-processing that you're using can handle those unique features in your corpus. Okay. In this notebook, I also have some background on general pre-processing. If you want to check that later, feel free to, but we're actually going to pass by that at this point and move on to continue talking about social media. Okay, so we're going to use some real data from Twitter as examples here. I want to show examples live on the screen here, so I don't want to work with tweets that the authors probably didn't expect to be widely viewed in any other kind of setting. So we're going to just use tweets from very popular celebrities and politicians that they posted recently. The data here was collected using the TweetPy Python library. You can click here and read more about how to use that library, but we're not going to go into details actually today about collecting the data, so we can keep focus on pre-processing. You can access the data here, but if you ran that setup cell at the beginning, it's already been loaded into the Collab notebook. So you don't need to worry about setting that up here. Also, to get Twitter data, an important thing to note is you need to have a Twitter API account. Also something we won't cover today, but I just wanted to give a pointer to the Twitter API documentation that will tell you how that works, how you can get your own account and collect your own data. Okay, So let's take a look at some of the data that we have here. Looking at just the first 5 rows of data, these are the different attributes that we have in this CSV file. So we have the username, the type. This is just something for us to be able to play around with like categorization and things later. It's something I manually just labeled these accounts to give some kind of extra label that we can work with. Each tweet has a unique ID that you can use to go retrieve the tweet again through that API and collect any up-to-date information about it, the time it was created, and then we have the actual text. The expanded URLs field I put here because we do want to talk a little bit about URLs. And you've probably noticed if you use Twitter that a lot of URLs in tweets are shortened using a URL shortener. So it appears as something like t.co/something. But when you click the link, it would actually redirect to another web page. So Twitter actually gives you that information separately. The tweet text itself, and then the URL that any of the shortened t.co URLs would redirect to. So we can actually get that information. Okay, so that's what the data looks like. I want to look at a few other examples from the data set. These are ones I kind of pre-selected to show a little bit of variety of types of things that are being said. So we have examples of different users and things that they have tweeted recently. So I wanted to take a little bit of time to just look at this, think about what do you notice in this data. I think it's always important to look at samples of your data, see what's there, and try to have a good understanding of the range of different kinds of phenomena that might be there, different kinds of features, information that might be there. So when you look at these, think about what you notice that might not be handled well by traditional text preprocessing. So some examples I show in the general text preprocessing are using like the natural language toolkit or spacey text preprocessors. Those usually do things like splitting apart words on spaces, maybe things like lowercasing, identifying what different tokens are, maybe removing extra characters, some of the things we talked about at the beginning. Okay. So as you're looking at this, you might be seeing things like emoji, things like repeated special characters, hashtags, different types of capitalization, mentions of other accounts, links to other pages or to other tweets. You hear a long string of all caps. Okay. And some other tweets like this one, for example, if you're removing at mentions and removing emoji, then you have no data left at all for these tweets. So some pre-processing that's too strict, you can even be left with nothing if you apply that to tweets. But there's definitely some kind of information or something that's being said here. And so it'd be interesting to be able to learn more about that. Okay. Anyone else in the audience feel like sharing anything you notice that's interesting or special cases that you're wondering about how we might handle that?
I find interesting the using of you, the single character you, instead of the pronoun, like do you.
Yeah.
This is one thing. Yeah.
Yeah, that's a good one. So maybe like ways that are like less traditional ways of representing certain words. Yeah, which I think those are kind of interesting because also in this tweet, which isn't very long, sometimes people have argued, well, tweets have a character limitation, so it forces people to do that. But even this one, there's no reason why it couldn't have been the longer version. So it's also kind of been adopted as a way of talking in a lot of electronic contexts. I see in the chat also a list of items, like from AOC. Okay, that one's interesting too. Yeah, because it's not really, this part itself isn't really a sentence, right? And it has emoji mixed in along with these, and even using emoji for different purpose, right? Like, I don't think this is a standard hand warmer emoji, but it's being labeled in that way. So that one's actually really interesting. How did I manually label it? There's no sophisticated process. It was just looking at the accounts and what I know about them and trying to come up with a set of categories that made sense and wasn't too many different categories. But there are some that maybe isn't perfect. Like I think Zendaya, I wasn't sure to put music or acting or something like that. So some people who do multiple things, but yeah, so I wouldn't use it for any kind of scientific conclusions. It's just so we can have something to try out some things later. Yeah, those are all really interesting features though. Anything else anyone noticed?
I noticed the word cooking in, I think, the Rocks tweet. So it looks like dropping the G there.
Yeah. Which is kind of a signature of the Rock thing to do, right? That's kind of his catchphrase of what the Rock is cooking. Yeah. But you might have that kind of, and I feel like based on my experience, it's more rare to actually have people put the apostrophe here rather than just dropping that totally. Okay, cool. So all good things. We won't cover all of those, but maybe if we have time at the end too, we can even talk, like brainstorm a little bit more about different things we can do for handling some of those cases that we saw. Okay, so I won't make the list now. I think we'll move on to this part, talking about some Python libraries that are out there that are kind of tailored for social media pre-processing steps. So there's this one called TweetPreprocessor. So I want to show you briefly what this one might do. I'm comparing to Spacey, which I needed to. Sorry, I missed the running something here. Okay. The Spacey processor giving something like this. That's kind of a standard text preprocessor. So the original text we're looking at here, preprocessor is #awesome, thumbs up, and then a URL. So here we get preprocessor awesome. So stop words have been removed is being a stop word there. And then special characters removed from the URL, so it becomes something that's like that. So the tweet preprocessor has some different modes. One is clean, which kind of gets rid of the social media specific features. So you just get preprocessor is, and then the entire hashtag itself is gone. Or kind of like we talked about earlier, you can do the tweet preprocessor tokenize. That will give you these special characters or special tokens with these $signs on either side that indicate that a hashtag was used, an emoji was used, and a URL was used without specifically encoding which one it was. So you might wonder why we would even want to do that. So this can actually be useful, especially if you don't have a lot of occurrences of the same hashtag or the same emoji or URL. Just knowing that that type of feature was used in the first place can be important information that you can have and can help you to generalize. So maybe tweets with hashtags have more engagement or something like that. Tweets with emoji have more engagement or more higher emotional intensity or something like that. So even just the count of these particular features can be important sometimes. again, how do we know what to do? How do we know if we should remove these, keep the original hashtag, or replace with the hashtag symbol here? Again, part of that depends on your end goal and your application, what information you need to be able to do that. And you can also always experiment with different approaches and see what works. Okay. Another tool that's out there as part of NLTK, so the Natural Language Toolkit, which is a common Python library for doing a lot of NLP stuff that you might be familiar with already. That library has a lot of standard pre-processing functions, but also has a TweetTokenizer in there that you can use that's made specifically for dealing with Twitter data. So it just handles the way it splits tokens a little bit differently. So if you want to use this one, in the first example, we do the TweetTokenizer tokenization. In the second example here, it's just using the regular word tokenize function from NLTK. So you can see in the TweetTokenizer, it does a little bit better at keeping this emoticon smiley together, keeping URLs together, things like that. So it changes where it decides the word boundaries are a little bit differently. That might help you a little bit when you're dealing with social media data, especially if you're already using NLTK for some of your pre-processing steps. You might be able to just switch that tokenizer and keep some content a little bit more organized that way. Also, the hashtag Twitter is another difference where this has been left together as a single token instead of splitting to hashtag and Twitter. Okay. Another one is Twitter text Python. This has a parser that allows you to extract some different elements that might be important in a tweet. So if you pass a tweet to this parser, you're able to then grab things like who is being replied to, different users that are mentioned, hashtags that were used, and URLs. So if you want to quickly parse through and get those kinds of features from some tweets, this is a good library that you can use to do that. And then ekphrasis is, I think, a really nice solution to do a lot of different things with Twitter data. It's really customizable, and there are a lot of different components that exist in there. I'm just showing the example setup that they have on their GitHub page, but there's also more information there about how you can kind of tailor it to your applications. But it handles a lot of things, including normalizing a lot of different types of tokens that you might see, like URLs, emails, percentages, money, phone numbers, those kind of things, which you might be able to detect with regular expressions. It can also annotate some social media specific features, things like casing, or whether words are elongated, or repeated characters at the ends of words. Also doing some Twitter specific segmentation, spell correction, and even segmenting hashtags, which is something we talked about earlier. So trying to take a hashtag and splitting it into what are the individual words that are part of a hashtag, which is pretty cool. Okay, so let's set this one up. When you create the processor here, it will take a little bit of time to load some word statistics, because actually to be able to do the splitting of hashtags and things like that, it relies on some statistics about what different words are and how often they appear in different sequences. So we can load that and then run it on some example text, and the output looks like this. So you can see for this can't wait here, it's been lowercased. So that might be what's useful for your next step of your pipeline. Maybe it expects lowercase text, kind of a more standard form. But also we've got these tags, all caps. So kind of an XML format where it's opening tag and closing tag for all caps, indicating that this can't wait was originally in all caps. So we haven't actually lost the information that that was in all caps. It's still there, but we have a representation of the individual words that we can then use for the next steps of our pipeline. And similar things are done for hashtags. So we actually have hashtag tags here. And then Twin Peaks, which you can see came from this hashtag, which was Twin Peaks mushed together as one word. If the capitalization is in this way, where the beginning of each word is capitalized, that might sound like an easy task to split apart the hashtag. But actually, you can see it also works for these other kinds of hashtags like David Lynch TV series. It's able to split those apart into individual words that you can then use for your other analysis. Or if you need to have the information about whether or not it was a hashtag, that's still there. If you need information about how many hashtags did this user use, you have that. And then you can also go through and remove these tags easily with like a kind of like HTML or XML cleaning type of library if you want to, and just get the plain text. There's a lot you can do with this type of format. So I think this is a really cool one that does handles a lot of features. Another good one, this where it says sucks really long with a bunch of views, has been normalized here, but also tagged that it was elongated originally. So that's another thing that might be interesting. You can see how many elongated words different users might be using, or how that relates to other kind of variables that you're interested in measuring, or even which words are most often elongated. What else do we see? Even converting this emoticon to laugh, something like that. Okay, and you can turn on or off all of these features based on the way that you set things up earlier. You can even put in your own functions and add them to the pipeline if you want to. So that's a really nice one, I think, if you just want something off the shelf that covers a lot of different interesting cases. You can go grab that one and start using it right away. Okay, so those are some tools that might be good to be aware of that exist for dealing with Twitter data in Python specifically. Now let's go and move on and look at some of the interesting features that we talked about and look in a little bit more detail on how we can think about those. So we're going to look at emoji, hashtags, and URLs. So thinking about emoji, I want to give some background about how emoji are actually represented under the hood. So any digital text that we have in our computers, even these letters we're reading on this collab notebook, are represented as a sequence of binary codes to kind of make a simplified version of it. So your computer needs to translate these codes into the correct characters that you see on the screen. And to make sure that the codes are translated to the same characters on your screen as they are on my screen or on other applications, we need to have a agreed upon standard mapping from these binary codes, that's like computer data, to the actual characters that we see. For web data, the Unicode standard is widely used to have that mapping between these codes and characters. It contains mappings for over 144,000 distinct characters. So it's able to represent a lot of different things, and this includes emojis. And so more and more emojis are even being added over time. You've probably seen, and every once in a while you'll update your phone OS or your computer and you get a new set of emojis that you can now use. So that's usually coming from Unicode. They've been introduced as part of the Unicode standard, and then your like Apple or Google or whoever is developing your OS that you're using is adopting these new representations that have been added to the Unicode standard and putting them into their platforms. And then everyone is able to eventually see the same things. But you've also probably noticed sometimes there's a lag where you've updated and someone else hasn't updated and they can't necessarily see the new emoji that you have yet. Okay, so this is something that's changing and growing and expanding, but that's a little bit of background just about where these come from. And we can actually see what this looks like if we have a binary sequence. So this small b in front of this string in Python is saying this is not just a normal string, but a binary sequence. Okay. been inactive too long. And we can decode this just like this with the decode function using the UTF-8 format to see that this sequence of bytes is actually this fire emoji as a string representation. And we can go the other direction and encode this into UTF-8, and you see this sequence of bytes. This is just a hexadecimal format way to represent the bytes. It's not too important to know for now, but I just want to show you that there is some kind of sequence of binary underneath. And sometimes you'll see, like, if you go to Emojipedia, if you're familiar with that, each emoji has a code point that they'll mention. If you need to get that, you could use this kind of format to see what that is. So like if we were to go to this link, and by the way, if you look at the URL, you'll see this F09F94A5 sequence. It's exactly the same as this byte sequence that we decoded before. And if we follow this URL, it's the page for the fire emoji, and you can see this is that code point that I mentioned as well. Okay. Also, you have these short codes, which are kind of the text descriptions of these, and we'll show how to get those from Emoji in just a second. Okay. So let's take a look at another emoji. This one here, you can see has a really long representation. It's much longer than the fire emoji only that we had before. So why is this one so much longer? So as we talked about before, a lot of emoji are actually compositional. They can be modified to include different kinds of hair, lengths, skin tones, things like that. And those modified emoji are actually represented by multiple parts. So we have the base code point, which will usually be about the size here of this fire emoji. But we also have a bunch of modifiers, which is all of the other stuff at the end, which tells us how to modify that base emoji to this other emoji that we have. And we can actually go in and see the individual parts in these emoji. So I'm not manually typing in the school or this man. It's just grabbing the first 8 parts and the rest of this man teacher emoji that we have. And then decoding both of those parts to see which emoji they represent. And actually, we can break it down one more level and split the first part into this man plus this particular skin tone. So this emoji is actually, why it's so long is it because it actually has the encodings for all 3 of these individual pieces put together that represents this single compositional emoji that we have. Okay. So another thing, a minor thing to note, if we want to play around with this in code, there's a special joiner character, which is like this, that if we wanted to go back the other direction, we need to add that in the middle. So if we encoded this back into bytes, we need to put this joiner character in between, and that's kind of a symbol that just says, take these 2 emoji, combine them together. But we can actually encode both of these and just concatenate this sequence. And then when we decode it, we get that teacher emoji. Okay, so I have a little function here that can take any emoji and split it apart into its pieces if you want to play around with that. Here it's just going through this list of different emoji and printing out all of the constituents that we can get there. So you can see those joiner pieces that I mentioned. There's also a variation marker which can be used to specify different variations. So you might see that as well. And these are kind of interesting even to know how people represented it, like this one of like a person plus skin tone plus joining with the scales turns it into a judge. Okay, and not all of them have these pieces in them. So some emoji are just the emoji itself. So you won't be able to split everything, but so many you can, and the amount you can do is growing. Actually, they're even adding, I think they just added the new handshake emoji with different color skin tones for each of the hands that you can use. Okay, I think all that's interesting. I hope you do too, but we're here to talk about pre-processing. So what does this actually have to do with text pre-processing? So I think one interesting use case is looking at how people use skin tone and emoji and how maybe people choose to represent themselves or represent others that they're talking about in their tweets. And there's some really interesting work on this that you can check out if you want to see how people are actually doing this across a bunch of different countries and in different cases. In our case, I just want to show an example of how we can apply this knowledge and do some quick analysis of the tweets that we have. So what I'm going to do is first go through the data set that we have and just count the emoji that are being used by each user. So we're just using the NLTK TweetTokenizer, the one I showed before for now. We're tokenizing the text from each of the rows in our data set, and then we're keeping just the tokens that are in this emoji.unicode emoji. So this emoji library in Python, and then this just gives us a big list of all of the emoji, what's an emoji and what's not. Okay, we've just done that. So then we can go through and look at the top 5 emoji components. Again, so we're splitting these apart into these individual pieces for each user. So you can see here some of the skin tone modifiers are showing up. And you can even see some users do use multiple different ones, maybe in different situations, which could be interesting to look into. And then you can see a lot of other interesting emoji that maybe says something about it. Federer tweeting a lot of tennis balls. I think stuff like this makes sense. And here, Elon Musk not using mini emojis himself. Okay, so this is just the individual pieces, but maybe we want to dig into this a little bit more and see for each user, which, let's say we want to see which skin tone modifier was used most often. So we just pass in a set of the different emoji we're interested in. If you change this to a different set of emoji, it would tell you which emoji from that set someone is using the most. And then we can just go through, we're looking at the same set of counts, but for each skin tone emoji, which one is used most by that particular user, which might be a really interesting thing to look into for some computational social science studies where you're interested in not just the range of emojis that someone used, but maybe which types of modifiers are they using. And you could do a similar thing, even looking at, do they choose the like man or woman modifier to the emojis, which is usually what they're called. Really what it does is just change the length of the hair of the person. And there's a video at the end I posted from someone at the Unicode consortium who talks about assumptions about how gender is not the same as hair length and race is not the same as skin tone. So it's important to keep those things in mind. It's not like we've now identified definitely the race or gender of any person just based on looking at emojis, but it's an interesting feature of their communication of how they use these things. Another important thing to note, skin tone modifiers have only been around since 2015. So if you have a data set from like 2012, it's not going to be in there. It's not necessarily available on all platforms and data sets. So it may or may not be there. Okay. Another thing I mentioned that we could do is convert emoji into plain strings. So maybe you have a model that has a representation for what to do with the token pizza, but not the pizza emoji. But maybe you can say, let's treat them in a similar way. Maybe we think it has a similar meaning. So we can just maybe collapse the representation and convert from the emoji into the description. This emoji library has a really simple way to do that. It's called demojize, and you can just pass emoji and it will give you that. Another option is to include pizza plus the pizza emoji itself. So there's some work with the link here that shows for like sentiment analysis tasks, it can be helpful to actually have both as features. So you get this extra information, so the model's able to leverage what it knows about the word pizza plus the emoji pizza, or maybe more useful, like the word smiling and the emoji that is called smiling face or something. So then you automatically get some information that smiling may be a positive sentiment, even if you haven't seen that emoji before. So if we use the demojize, it just gives us these representations here. If we want to actually have both, I just have an example here of some different ways we could include that. So having this emoji and emoji function, we have the pizza emoji plus the word pizza, or the steaming bowl plus the word steaming bowl. Or maybe we want to replace emoji with just a symbol that lets us know we have seen an emoji and then the word. Okay, so that's something we can do. In some cases, it might help. One quick thing to point out, with tokenizing emoji, NLTK's TweetTokenizer doesn't really handle the skin tone modifiers. So if you try to tokenize something that has a skin tone modifier applied, it will split it. If you want to keep it together, I would recommend this space emoji. It's part of Spacey. You can add this emoji tokenization to your pipeline there. Okay. Hashtags. So we can also do something similar to what we did with emojis, but just with hashtags. So duplicating the hashtag and the word itself, that might be interesting. You might ask, why not just replace hashtag good with good? Maybe that's all we need to do. But you'll find oftentimes the hashtags themselves have an important meaning on their own, and it's not always a good idea just to convert them to words. So hashtag me too means something very different than just the words me too seen in other contexts. And same with the other hashtags that might be associated with a certain movement or something that's happening in the world. So those might be really important to keep the original hashtag, but you might also want to split it apart to look at the individual words. You can also use corpus statistics to do this. So maybe if a hashtag is used more than n times total, you don't split it and assume that's kind of a trending hashtag that a lot of people are using, but maybe smaller hashtags that only one person used or a few people, you split it into its pieces. And to split it, we've already shown with this ekphrasis library how to do that. It's using the Viterbi algorithm. You can read more about that here if you want to. But here you can see an example. We could split it like this. I'm feeling hashtag some kind of way, but still indicate that the hashtag was there. Also get the individual words. There's also a pointer here to another paper that's using neural networks for hashtag segmentation that has some promising results. So if you want to check that out and you're really interested in kind of pushing the limits of hashtag segmentation, that might be interesting to you as well. Okay, and the other thing I wanted to talk about is URLs. So one thing that's really simple and a useful thing to do, I think, with URLs, rather than throwing them away, at least convert them to just get the domain level. So if we have a longer URL, we can use Python's URL lib and parse that, and you can use this attribute called netloc, and it gives you the domain that the URL comes. Sorry about that. So if we do something like this, we can go through the data set in the same way that we did before with emoji, and look at the top domains that are mentioned in tweets by different users. So if we were just to count individual URLs, we probably wouldn't get very high counts for anything because the same URL isn't shared that many times. But if we count the domains, we start to see, for example, like headgum comes up as a domain that's consistently posted by this account. And you see similar things happening for a lot of other users that are there. So I think that's a useful way to get some quick information from domains. There's also some work on how we can use this to detect whether a news source is reliable or not. And there are some known lists of unreliable news sources. This might help with fact checking or misinformation detection, things like that. So even knowing what sources are shared by an account. Okay. Also for URLs, something else you might want to do is actually go follow the URL and get some information from that page itself. So Python also has ways that you can do this. You can go to a link. You can use the URL lib to open the link, get the contents, print that out. But you'll notice this has a bunch of HTML tags and extra stuff you might not want. I would recommend using the Beautiful Soup library to clean the HTML contents. So this should give you just kind of the words you would actually see if you went to that web page, which this is just a Python page that has a bunch of text here, but this should work for other web pages to get from all of those HTML tags just to the actual words you would see as someone viewing that web page. And then you can process those however you like. So maybe this gives you extra features. Maybe you detect topics that are on the web pages that are shared by users or anything like that. So you get a lot more information than just looking at the URL itself, and definitely a lot more than throwing away the URL. Okay. So I want to show now quickly how to kind of combine a bunch of these different pieces together if we want to, and create our own preprocessor that takes into account some of the things we've talked about. So this is just some setup here, defining some different components that we're going to use. And then this one, again, I'm just putting all of these pieces so you can see doing lowercasing, tokenization, what we're doing with emojis, hashtags, user mentions, anything like that. This isn't meant to be a perfect solution that handles everything, but just so you can have something to play around with. Again, you can also use some of the Python libraries I mentioned earlier, just off the shelf to do this as well. But if you want to kind of dig into it and see what's happening a little bit closer to the code, you might start with something like this. And this is the one I wrote. This is what it's doing to text that looks like this. It's converting it to something like that. Again, is this right? Is this wrong? It depends on what your application is, what information you want to extract from it. But we've converted to another form that might be useful. Again, you can also use some of the off-the-shelf tools. This is another example of what might have happened. And I'm highlighting colors of kind of what's changed between the two. Okay. So yeah, before we wrap up here, I want to show an activity that you can then go and take and play around with some of these things later and try some of these things out. If you load this notebook and you haven't been running all of the cells as we've been going, you can just run this catch-up. This will load all of the functions and everything from the entire rest of the notebook. So if you just want to jump down to step 5 here, run the catch-up. That could take a minute to run. But then I've left this my preprocessor function. That's just a copy of the one we just showed. But you can go ahead and change anything you want, modify, try different things here. And then you can see what it does on some sample text here. You can also try it out on the tweet data set. So this block here, if you run it, it will grab random tweets from the data set and it will pre-process them with your function that you define, and it will show you before and after what it looks like. So you can kind of see a lot of examples of what's happening in the data set. You can click the stop button when it's running to stop it, or it'll ask you to press enter to continue. Here, now that's loaded, I can kind of show you. So if we press enter, it'll show you a new tweet. It'll show you how it's been pre-processed before and after. So I think this is also a good practice to kind of get an idea about what's actually being changed. And then, yeah, an easy way to stop it is just hit the stop button. Okay. And then I have 2 test cases you can play around with here as you're playing with your preprocessor. So maybe once you see this and you like how the changes look, there's some code here you can use to find the top tokens for each user, sorted by TF-IDF score, where we treat each user as a document. So words that are used by this user that aren't used by all users very often, all other users in the data set. So you can run that, do your pre-processing, and then using those labels that I mentioned before of the categories of users, you can also play around here with training a random forest classifier to detect which type of user wrote a given tweet. And The only thing that's happening here, other than kind of a normal sklearn machine learning setup for text, is in the count vectorizer. That's a thing that goes from strings of text to like a bag of words representation. You can give a custom preprocessor. So all I'm doing is passing the name of the function myPreprocessor, which is the one you can write here. So you can change that, and then that preprocessor will be used as part of this text classification pipeline. You can try, and it will show you on the training set and test set how well you're able to do that prediction. So those are some things you can play around with, try some pre-processing, see what happens with this social media data, and a few questions to take some time to reflect on after you do that, as well as some additional pointers here at the end of the notebook if you want to read more about some of these topics that we've talked about. So that's it. Thanks everyone for following along, and I hope this has been helpful for you to think a little bit more about some tools and strategies you can use as you're dealing with pre-processing your social media data.
Great. Thank you so
Thanks a
much,
lot.
Steve.
Yeah, no problem.
Maybe a minute or two for questions. Does anyone have questions?
Yeah.
I just have a quick question. I would be interested in learning, what do you usually do with the mentions? Like, I can think of one use cases of mentions where mention represents an interaction between two people. And yeah, coming from a graph analysis background, I can always think about that as adding weights to the interaction between people or between members. But how do you do that usually when you analyze this in the NLP?
Yeah, that's a great question. So I think exactly what you said. So building a graph of user interactions is one way that's often used, and having a weight based on how many times one user mentioned another, and that even gives you a kind of directed edge in your graph. So that's kind of useful for graph-based analysis. So I will say it can be, sometimes you need a lot of data to build a good graph. So in this case, where we only have a subset of users and only a subset of their tweets, it's hard to get a graph that's very dense. You might have a few. Actually, I have seen in this, there are a few of even these celebrities tweeting at each other. But you would need a substantial amount of data to build that well, but it can be super useful and give you the context. But even knowing if something's a reply or not can be useful. And when someone is mentioning someone else, it can also help you build like a conversation between the two users, which can give you context just for the text way if they're kind of talking at one another back and forth. So that can be useful. Just knowing that someone mentioned someone else can also be a useful feature. So maybe I can add this one later, but in some work from Abir Al-Dael and Walid Magdi on stance detection, I know they looked at users mentioning other users as like a feature about that was really helpful for stance detection, actually. So the interesting thing there, I think, was they were looking at like Donald Trump and Hillary Clinton. If you were a Hillary Clinton supporter, you actually mentioned Donald Trump in your tweets a lot, and vice versa. But you would follow and like more stuff from the person you do support. So it was actually an important signal there where they were kind of maybe saying at Donald Trump, you're wrong, blah, 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 or at Hillary Clinton, you're wrong, blah, 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 for the people they didn't support. So that's another kind of interesting thing you can do with that. But yeah, again, it kind of depends on the use case, and maybe sometimes you do remove it and just keep the fact that it's a reply.
Great. Well, unfortunately, we're out of time. So thank you so much, Steve. And please join us in a couple of weeks for our next tutorial, everyone.
Yep. And shout out to that. The next tutorial is actually by Katie. It's going to be all about quantifying uncertainty. I'll toot your horn if you're not going to toot it. So please come, talk with Katie about how to deal with sort of uncertainty in your analysis throughout the whole analysis pipeline. But in the meantime, thanks for coming. And thank you again, Steve, for awesome tutorial. Yeah.